Chapter 8 Classes and Objects in Java. As learned earlier, object and class are fundamental parts of object-oriented programming. Java is an object-oriented language. This chapter explains how to create a class and object in Java programming. After studying this chapter, we will be able to get a clear picture as to what are objects and what are classes in Java. Introduction. A class contains both data, that is, referred to as attributes, and program code, that is, functions referred to as methods. In the previous chapter, we wrote programs using a class that contained a single method named main. When the class was executed, the main method was called and the application ran as a normal program. We have not used any data members in those examples. While it is possible to use only a single class in a Java project, this is not a good practice for large applications. When designing software, we should divide the entire application into simpler components that perform logically related tasks. For each such component or module, we may create a class. Let us understand the concept of class and object in Java programming through an example of room. A room of a house, hostel, hotel, or school possess common characteristics. Each room can be uniquely identified by its properties like length, width, height, number of windows, number of doors, and direction. For simplicity, let us consider here length, width, height, and number of windows. We will now write a Java code as shown in code listing. To create a class named room with the attributes length, width, height, and windows and 3 methods. The first method will be used to assign values to attributes. The second method will calculate the area, while the third will display its attributes. Thereafter, we will write code to use this class. Here, first of all, code is written to create a class named room. Thereafter, code is written to create objects of class room and use its methods. To do so, we have created another class named roomDemo containing main method. In a source file, these classes may appear in any order. Here, we have separated creating room class performing logically related tasks and using this class in application class roomDemo. When a program contains 2 or more classes, only one class can contain main method. This figure shows the execution of the code in SCITE editor. In the given example of roomDemo application, as shown in figure, following operations are performed. 2 objects R1 and R2 of classroom are created first. They are initialized with default values, that is, numeric values are 0 by default. Contents of these 2 objects are displayed using display method, invoking setUtter method with numeric letters as parameters. Attributes of room objects are modified for both the objects R1 and R2. The updated contents of 2 objects are displayed. Finally, area of both room objects is displayed. Here, area method is invoked to get area, class in Java. We have already written one program that uses class. Let us now learn the syntax and other details of how to create class, objects, and use them in an application. A class is a template for multiple objects with similar features. Classes embody all the features of a particular set of objects. For example, classroom is a template for all rooms with their common properties. In Java, a class is defined using class keyword as follows. Every class we write in Java is generally made up of 2 components, attributes and behavior. Attributes are defined by variables in a class. Behavior is defined by methods in a class. Methods are used to access or modify attributes. In code listing, we have defined a class name room with attributes defined by variables named length, width, height, and windows, and behavior by methods named setUtter, display, and area. Another class is created just to create an application using room class. Creating objects. Creating an object from a class requires the following steps. Declaration. A variable, that is, a reference variable name of type class, is declared with syntax angle bracket class name angle bracket over angle bracket variable name angle bracket over. Instantiation. Keyword new is used to create the object by allocating memory. Initialization. Constructor, that is, a special type of method, is called to initialize the newly created object. In Java, a class is a type similar to the built-in types such as int and boolean. So, a class name can be used to specify the type of a variable in a declaration statement, the type of a formal parameter, or the return type of a function. To declare an object of class room, use following statement. Room R1, semicolon. Declaring a variable does not create an object. This is an important point to be remembered. In Java, no variable can ever store an object. A variable declared using class type can only store a reference to an object. So, variables of class type are also referred to as reference variables. Here, R1 is a reference variable. Next step is to create an object. Using new keyword, we can create an object. Operator new allocates the memory for an object and returns the address of the object for later use. Reference is the address of the memory location where the object is stored. In fact, there is a special portion of memory called the heap, where the objects live. When an object is created, in addition to allocating memory, a special method called constructor is executed to perform initial task. We will learn about constructors later in this chapter. Let us create an object of type room and assign its address to variable R1 as follows. R1 is equal to new room. Here, parentheses are important. Don't leave them off. With empty parentheses without arguments, a default constructor is called. It initializes the attributes, that is, variables of the object using default values. The parentheses can contain arguments that determine the initial values of variables. This is possible by using user-defined constructor. When statement R1 is equal to new room is executed, remember that object is not stored in variable R1. Variable R1 contains only address of an object. Both the above steps used to declare and create an object can be combined into a single statement as follows. Room R2 is equal to new room. Variable R2 contains a reference or address of memory location where a new object is created. It is also to be noted that the class determines only the types of the variables. The actual data is contained inside the individual objects and not in the class. Thus, every object has its own set of data. In code listing, we have created two objects, R1 and R2, using new operator. These objects are allocated different memory space to hold their data values as seen in figure. In Java, when objects are no more needed, the memory is claimed back for reuse. Java has a garbage collector that looks for unused objects and reclaims the memory that those objects are using. We do not need to do any explicit freeing of memory. In object-oriented programming, that is OOP languages, creating an object is also called object instantiation. An instance for an object is created by allocating memory to store the data for that object. An object that belongs to a class is said to be an instance of that class. Thus, an instance of a class is another word for an actual object. Class is an abstract representation of an object, whereas an instance is its concrete representation. In fact, the terms instance and object are often used interchangeably in OOP language. Each instance of a class can hold different values for its attributes in variables declared in a class. Such variables are referred to as instance variables. Instance variables are created at the time of creating an object and stayed throughout the life of the object. Instance variables define the attributes of an object. The class defines the kind of attribute. Each instance stores its own value for that attribute. To define an object's behavior, we create methods. In Java, methods can be defined inside a class only. These methods can be invoked using the objects to access or modify the instance variables. Such methods are known as instance methods. Instance methods are used to define behavior of an object. Invoking a method is to ask the object to perform some task. In code listing, we have defined a class named room with instance variables length, width, height, and windows, and instance methods setUtter, display, and area. To summarize, objects are created with the new keyword. The new keyword returns a reference to an object that represents an instance of the class. All instances of class are allocated memory in data structure called heap. Each object instance has its own set of data. Accessing instance variables and calling instance methods. Instance variables and instance methods are accessed via objects. They can be referred by using dot operator as follows. Angle bracket object reference angle bracket over dot angle bracket instance variable or method angle bracket over. For example, we can refer to length of room R1 using R1 dot length in a program and invoke method R1.display that displays attribute values of room R1 as can be seen in code listing. Note that here dot is an operator and associativity of dot operator is from left to right. Remember that data should be protected from such direct access from anywhere in the program. Such protection is possible with the use of access modifiers that we will see later. When the instance variables are referred within the methods of the same class, there is no need to use dot operator. For example, in code listing, in method display, instance variables are accessed without using dot operator. This is possible because method is invoked using reference variable R1 and thus referred instance variables are considered to be of the corresponding object stored at R1. As studied, when we only declare an object using class, object is not created. In this case, reference variable does not refer to any object and its initial value is null by default. Use of such null reference or null pointer is illegal and may raise an exception. So, referring instance variable or invoking method with null reference will give an error. Try following code. Room R1 semicolon / null value assigned to reference variable by default. System.out.println in bracket R1.length semicolon / illegal. R1.display bracket semicolon / illegal. Class variables and class methods. As discussed earlier, when an object is created using new keyword, memory is allocated from heap area to store the value of its attributes. Thus, every object has its own instance variables occupying different space in memory. Now suppose we want to have a total number of windows of all room objects created so far. To store this value, it requires only one variable per class. It is meaningless to keep this variable as an attribute of each object. Actually, it is not an attribute of an object, it is an attribute of a class. Thus, when there is a need to have some variable that is shared by all object instances of the same class, the variable should be allocated the memory only once per class. It means that Variable belongs to a class and not to an object. Such variables can be declared within a class using static keyword before data type, and these static variables are called class variables. Values of instance variables are stored in instance memory allocated for the object, whereas values of class variables are stored in class itself. Let us declare class variable taught windows by adding following statement in class with instance variables. Static integer taught windows. Static variables can be accessed without creating an instance of a class. For example, if we try to display the value of taught windows without creating any object of the classroom, it will display. Just like class variable, class method can be defined using static keyword in front of the method definition. Try following method in room class to display total windows. Class variables and class methods can be accessed outside the class using angle bracket class name angle bracket over dot angle bracket class variable slash method name angle bracket over. For example, room dot taught windows, room dot display total windows. Note that class numbers, that is variables and methods, can be referred without class name by the methods of the same class as shown in the code listing of figure. The output of the code shown in figure is given in this figure. Here, we have written an additional instance method setWindows that updates total windows by subtracting the old number of windows and adding new number of windows in a room. Method setWindows is defined in the same class, so it can access class variable taught windows without class name. In main method, that is defined in room demo static class, that is defined outside room class. Class variable taught windows is to be accessed as room.taught_windows using class name. Class methods are global to the class itself and available to any other classes or objects. Therefore, class methods can be used anywhere regardless of whether an instance of the class exists or not. Now, when should we use class methods? The methods that operate on a particular object or affect that object should be defined as instance method. Methods that provide some general utility but do not directly affect an instance of the class are better declared as class methods. For example, consider a function that determines whether a given number is prime or not. This function should be defined as class method. The code listing and its output is shown in this figure. The designer of Java have already provided a large number of built-in classes with such class methods. In previous chapter, we have used static method square bracket without creating any object of class math. It is to be noted here that the main method that we have defined till now is also a class method. This is the reason we use keyword static while defining main method. As seen here, the static and the non-static portions of a class serve different purposes. The static definitions in the source code specify the things that are part of the class itself, whereas the non-static definition in the source code specify the things that will become part of every instance object belonging to a class. Points to remember: class variables and class methods can be accessed using a class name or reference variable. To increase readability, it is advised to access with class name. Class variables and class methods can be accessed from instance methods also. Instance variables and instance methods can't be accessed from class methods, as class methods do not belong to any object. Classification of variables declared in a class. Local variables. Variables defined inside methods or blocks are called local variables. Formal parameters of the methods are also local variables. They are created when the method or block is started and destroyed when the method or block has completed. Local variables are not initialized by default values. Instance variables. Instance variables are variables defined within a class but outside any method. These variables are allocated memory from heap area. When an object is instantiated, that is, created, instance variables are initialized by default values. Class variables. Class variables are variables defined within a class outside any method with the static keyword. These variables are allocated memory only once per class and is shared by all its objects. Class variables are initialized with default values. Polymorphism, that is, method overloading. We have seen first two steps of creating objects, declaration and instantiation. The third step is initialization. It requires the use of constructors. Before we learn about constructors, let us see the way to implement polymorphism in Java. The word polymorphism means many forms, different forms of methods with same name. In Java, we can have different methods that have the same name but a different signature. This is called method overloading. The method signature is a combination of the method name, the type of return value, that is, object or base type, a list of parameters. For example, to find maximum of 2 integers, maximum of 3 integers, maximum of 3 double precision real numbers, and so on, one requires to perform similar task but on different set of numbers. In such scenario, Java facilitates to create methods with same name but different parameters. Finding maximum does not need creation of any object, so it can be defined as static class method. For example, you may try to define above forms of max methods and use in the application after looking the example of code listing given in this figure. Here, it uses polymorphism to print a line as per specified parameters. Call print line without any parameter prints 40 times is equal to character. Print line in bracket int n bracket over prints n times hash character. Whereas print line in bracket int n comma char ch bracket over prints n times specified character ch. Constructors. Constructors is a special kind of method that is invoked when a new object is created. Constructor can perform any action, but it is mainly designed to perform initializing actions. Till now, we have used class without user-defined constructors. Every class is having its default constructor, sometimes referred to as no argument constructor. Default constructor does not take any argument. It initializes the attributes of a newly created object using default values based on their data types. Constructor differs from general methods in the following ways. Constructor must have the same name as class name. Constructor does not have return type. Constructor is invoked implicitly only when an object is constructed using new operator. Constructor cannot be invoked explicitly elsewhere in the program. Like other methods, constructor can also be overloaded. It is possible with varying list of parameters. For example, we may write our own constructors to initialize the attributes of room object with different parameters as follows. Room in bracket float L, float W, float H, byte N bracket over to initialize length to L, width to W, height to H, and N windows to N. Room in bracket float L, float W bracket over to initialize length to L, width to W, height to 10, and windows to 1. Program seen in this figure shows the use of constructors. In absence of user-defined constructors in a class, objects are constructed using default no-argument constructor. It initializes the attributes using default values. In presence of user-defined constructors in a class, default constructor is no more available. An attempt to create an object using constructor without arguments, compiler returns an error. To solve this problem, we need to provide a user-defined no-argument constructor as follows: angle bracket, class name, angle bracket over, bracket, curly bracket, semicolon. In code listing given in this figure, try to create a room object in main method as follows and observe an error occurred during compilation. Room R3 is equal to new room. To solve this error, add user-defined no-argument constructor room, bracket, curly brackets, semicolon, and execute. See the successful execution as given in this figure. Visibility modifiers for access control. Access control is about controlling visibility. So, access modifiers are also known as visibility modifiers. If a method or variable is visible to another class, then only it can be referred in another class. To protect a method or variable from such references, we use the 4 levels of visibility to provide necessary protection. The 4 P's of protection are public, package, that is, default protection, protected, and private. Access modifiers public, protected, and private are used before the type of variable or method. When no modifier is used, it is the default one having visibility only within a package that contains the class. Package is used to organize classes. To do so, package statement should be added as the first non-comment or non-blank line in the source file. When a file does not have package statement, the classes defined in the file are placed in default package. Package statement has following syntax: package, angle bracket, package name, angle bracket over, semicolon. In this book, we will use default package. In all our programs, we have used the default access modifier till now. This table shows the type of access modifier and its visibility. Access modifier, public, type, default package, protected, private. Visibility, widest, type, triple arrow, double arrow, narrowest. We will now see examples of default and private modifier. Public. Any method or variable is visible to the class in which it is defined. If we want to make it visible to all the classes outside this class, declare the method or variable to have public access. This is the widest possible access. It provides visibility to classes defined in other package also. To provide public access, use access modifier public before type of variable or method. For example, public float length, public double area, bracket. Note that public variables and methods are visible anywhere and thus can be accessed from other source files and packages also. We have used public keyword with main method to make it available to everyone. Public static void main in bracket, string, square bracket, urged, bracket over, curly bracket, package that is without any modifier. This is the next level of access that has no precise name. It is indicated by the lack of any access modifier keyword in a declaration. This is the default level of protection. The scope is narrower than public variables. The variable or method can be accessed from anywhere in the package that contains the class, but not from outside that package. Note that a source file without package statement is considered as a package by default. So in our programs till now, it is as good as public. Refer the program shown in this figure. Here, rectangle class has two attributes, length and width. It also has various methods. We have not used any modifier keyword, so they have package protection by default. Due to this reason, they are directly accessible in another class, rectangle demo, defined in the same source file, that is, default package. Protected. This level of protection is used to allow the access only to subclasses or to share with the methods declared as friend. Thus, the visibility is narrower than previous two levels, but wider than full privacy provided by fourth level private. Use of protected protection will become more relevant when we use inheritance concept of object-oriented programming. Private. Highest level of protection can be achieved by using private protection level. This provides the narrowest visibility. The private methods and variables are directly accessible only by the methods defined within a class. They cannot be seen by any other class. This may seem extremely restrictive, but it is in fact a commonly used level of protection. It provides data encapsulation, hiding data from the world side and limiting its manipulation. Anything that shouldn't be directly shared with anyone, including its subclass, is private. The best way to provide data encapsulation is to make as much data as private as possible. It separates design from implementation, minimizes the amount of information one class needs to know about another to get its job done. Let us modify code listing given in this figure and declare length and width as private. As private members are directly available only within the same class. It does not give any error when accessed in area or display method. When they are accessed in main method of rectangle demo class, it will show an error. The modified code is shown in this figure. Here, we have used constructors in addition to private instance variables. Note the error in the output pane that says length has private access in rectangle. This means that it is not accessible in class rectangle visibility 1. The problem now is how to access private variables from another class. It can be made available indirectly by the methods that are accessible by another class. See code listing given in figure. Here, we have added two methods, getLength and getWidth, as no modifier is used. They have package visibility and so directly available in another class. Visibility private be here. Through these methods, we can get the values of private, length and width data fields, that is, instance variables. See the use of getLength and getWidth method calls in a last output statement in main method of class visibility private b. And mutator methods. When we restrict access to data by declaring them as private, our purpose is to protect them from getting directly accessed or modified by methods of other class. If we want to allow such data to be used by others, then we write accessor methods. If we want to allow such data to be modified by others, then we write mutator methods. Conventionally, naming of accessor and mutator methods is to capitalize the first letter of variable name and then prepend the variable name with the prefixes get and set respectively. Due to this convention, accessor methods are also known as getter and mutator methods as setter. Observe that in code listing shown in figure, we have used getter methods to getLength and getWidth methods. If we change the type of variable length, it will be hidden from other users. It affects only the implementation of accessor method getLength. If we want to allow other methods to read only the data value, we should use getter methods. If we want to allow other methods to modify the data value, we should use setter methods. For example, setLength method can be defined to set the value of length attribute using passed argument as follows. Void setLength in bracket float L bracket over curly bracket length is equal to L semicolon curly bracket over. Use of accessor and mutator methods will prevent the variables from getting directly accessed and modified by other users of the class. It may seem a little difficult to get used to this, as we need to write get and set method for each and every instance variable as per need. But this minor inconvenience will reward us with an ease of reusability and maintenance. Passing object as a parameter in a method. Just like variables of primitive data types and available built-in data types, objects can also be passed as parameters in a method. For example, we want to determine whether the area of invoking rectangle object is larger than another rectangle or not. For this, we may write a method where another rectangle object is passed as an argument or parameter. Let us add method isLarge in rectangle class as shown in figure and use it in main method boolean isLarge rectangle rect. Curly bracket open if bracket open area is greater than rect.area bracket close return true semicolon else return false semicolon curly bracket over. See the method call in if statement in the main method as shown in figure. Rect1 dot is large rect2. Here rect1 is a calling or invoking object and rect2 is an object passed as parameter. In the isLarge method, area refers to area of calling object rect1 and rect.area refers to area of an object passed as argument. Remember that parameters of primitive types are passed by value. The values of actual parameters are copied to formal parameters and then function is executed. Changes made to formal parameters are not affecting actual parameters. It is to be noted that object parameters are passed by reference. So, whatever modifications are performed to the object inside the method, the original object is affected as well. Here, an address and not value of the actual parameter is copied to formal parameter. Inheritance. Object-oriented programming languages provide reusability feature using inheritance. Inheritance allows us to build a new class with added capabilities by extending existing class. Inheritance models is a relationship between two classes. For example, classroom is a room. Student is a person. Here, room and person are called parent class. Classroom and student are called child classes. Parent class is also referred to as superclass or base class. In the same way, child class is also referred to as subclass, derived class or extended class. Whenever two classes have a relationship, we use inheritance. Common features are kept in superclass. A subclass inherits all instance variables and methods from superclass and it may have its own added variables and methods. Note that constructors are not inherited in subclass. For example, like room, classroom also has variables length, width, height, number of windows. In addition, it has number of benches, capacity of each bench to accommodate students. Similarly, subclass inherits all methods of superclass and it may have additional methods. Here, subclass classroom has additional methods show, display, get seats, and its constructor methods. This figure shows a class diagram that has a class named classroom derived from its parent class named room. See that the arrow points from subclass towards superclass. In subclass, only additional attributes and methods are to be shown. Note that a subclass is not a subset of superclass. In fact, subclass usually contains more information and methods than its superclass. When an object of subclass is instantiated, memory is allocated for all its attributes, including inherited ones. This figure shows the inheritance of superclass room and subclass classroom. In Java, to create a subclass, keyword extends is used in the class definition. Let us create a subclass classroom using existing classroom as shown in code listing. Now, let us add code to create a subclass classroom by extending superclassroom as shown in code listing. Subclass has two additional instance variables and benches and seats bench. 8 variable and seats bench denotes the number of students that can sit on one bench. It has its own additional constructors and 3 methods: show, display, and get seats. In subclass classroom, User-defined constructor and method show have reused the code written in superclassroom, as constructors of a superclass are not inherited in the subclass. Keyword super is used to call the constructor of superclass in the constructor of subclass. This call must be the first statement in the constructor. When there is no explicit call to constructor of superclass, no argument constructor of superclass is implicitly called as the first statement super. Method show is used to display attributes of classroom object. To display first four attributes inherited from superclassroom, we want to use existing code in display method of superclass. Now, display method is available in subclass also. In show, our intention is called display method of superclass. To do so, we have used super.display. When superclass and subclass have methods with same signature, a superclass method is said to be overridden in the subclass. Method display in subclass is used to override display method of superclass. It means that we want to display the details in a different way without reusing the display method of superclass. When such method of superclass is to be referred, we need to use keyword super with dot operator and method name. Here, we have used super.display in show method to invoke display method of superclass. Method getSeats is used to compute the seating capacity of a classroom. Let us use these classes in an application by adding code as given in code listing. Here, we have created objects of both superclass and subclass. All instance variables and methods are inherited from superclass to subclass. Thus, method area of superclass can be invoked using an object of subclass also using cr1.area. When overridden method is referred in an application using subclass object, it calls the method of subclass as cr2.display. The output of the code created by combining code is shown in figure. Private members of superclass. In the previous example, all instances have package visibility, so they are available for direct use in the entire package. If we try to access r1.length or cr1.width directly in main method, there will not be any error. If we change the visibility of instance variables of superclass to private, these variables are not directly accessible outside the class. Remember that these attributes belong to subclass also, but still private instance variables or methods are not visible even in its subclass. Modify declaration of instance variables in code listing to make them private as follows and observe an error in output as shown in figure. Private float length, width, height, private byte and windows. Remember that private members are directly available only in the class in which they are defined and nowhere else. To make them available elsewhere, use public accessor and mutator methods, getter and setter methods. Protected members of superclass. As studied before in the topic about visibility modifiers, protected members are available as private members in the inherited subclass. Modify the instance variables of classroom to protected as follows: protected float, length, width, height, protected byte, and windows. When we execute the modified code, we will get the same result as shown in figure. It is to be noted that Java does not support multiple inheritance. A subclass can be derived from only one superclass. Composition and aggregation. Composition and aggregation are the construction of classes that incorporate other objects. They establish a relationship between classes. For example, if we define class library, it has a reading room. Here, reading room is an object of the class room. Thus, library has a room. When a class includes objects of other class, it is also referred to as container class. Other examples are person has a name, address. Here, name is of the class name with three attributes: first name, middle name, and last name. Address is of class address with attributes house number, apartment or society name, area, city, state, country, pin code. Car has a steering, wheels and engine. Here, steering is of a class steering, wheel is of the class wheel and engine is of the class engine. All the three attributes of class car are components or parts of a car. Let us create class library that contains following attributes: n books, int, number of books in library; n magazines, int, number of magazines subscribed in library; n newspapers, int, number of newspapers subscribed in library. Reading room. See that reading room is not of the basic data types. It is of the type room class. Code listing shows the code to create class named room and library and use them in application named container.java. Observe the following points in code listing. In main method of class container, an object lib of class library is created using a constructor with 4 arguments. Last argument is R1 of class room. Method display of class library is invoked using lib object. In library class, an object reading room is an attribute of class room. Constructor with 4 arguments uses last argument R of the classroom. Assigns the values of room attributes using an assignment statement reading room is equal to R. Defines display method which invokes display method of room class using reading room.display. Note that display method is not overridden. We have not used inheritance. Readers may use another name for this method. Say show in class library and use lib.show in main method instead of lib.display. In this scenario, reader may think, why not to use inheritance? Why not to inherit library class from room class and add 3 additional attributes? Note that library is not of the type of room. There is no is a relationship between library and room. There is has a relationship. Library has a room used as reading room. So, we have used reading room of type room as an attribute of class library.